Hi everyone, I hope you are doing good. So today in this tree series, we will take a new DSA question, and this question got recently asked in one of the interviews. That is why I am taking this one. So let's understand the question first. The question is sum of nodes on the longest path, right? So by the name you can understand we have to find the sum of the nodes on the longest path, right? So the given given a binary tree, one binary tree will be given, right? It is not a binary search tree, it is a binary tree. You need to find sum of the nodes on the longest path from the root to any leaf node, right? If two or more paths have the same length, right, it could be the condition, right? It could be the situation where you may have multiple paths, longest paths, right? The path with the maximum sum of nodes value should be considered. In that case, if you have multiple longest path, in that case you have to return the maximum sum among the longest paths. That is what it is given in the question. Let's understand this by using the given examples here. Right. So here this one. Here what is the longest path here? This is the longest path, right? This is the longest path. 4, 2, 1, and 6. So the total is 13, right? 4 plus 2 plus 1 plus 6, that is 13. So here in this given example, first we have to find the longest path and then we can add. So that is the one, right? So this is 13. Now let's take another example. I hope you are getting it, right? This is the longest path and sum of the longest path is 13. That is why that is our answer, correct? Now check this out, this one, right? So here I think we have multiple longest paths, right? So if we go this one, then this is 3 length, right? If we go this one, this is 3 length. If we go this one, this is 3 length. If we go this one, this is also 3 length. So we have multiple longest path here, right? So now in this case we have to consider the maximum one, which is having the maximum sum, right? So if we go this one, so this is sum is 4, 2, 1, that is 7. If we go this one, this is 1, 2, 5, that is 8, right? If we go this one, this is 6, 3, 9, and this is 10, right? And if we go this one, then 1, 3, 4, 7, that is 11. So our final answer is 11 because this is the maximum with the longest path, right? I hope you are getting it. Here we have multiple longest paths, right? And longest length is 3, correct? And sum of the longest path among these longest paths is the maximum sum is 11. So this would be your answer, correct? Let's take any other example. Here, this one, right? So here longest path is 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So this would be our longest path, right? See here the interesting situation is the longest path sum is 1, 3, 4, 9, and this is 19, right? But see here this is 10, 15, 25. It is 45, right? Sum is here, maximum sum is here, but this is not the longest path. That is why we are not considering this result. Or you can say this one. This is 10, 15, and 22, right? 22. The sum is 22. But as these are not the longest path, that is why we will not consider these sums. I hope you are getting it. So first, our first priority is it should be longest path. Then only we will consider the sum, right? If it is longest path, if we have multiple longest path, in that case we will take the maximum sum of among the longest paths. But if it is not the longest path and still having the like greater sum, we will not consider that. We will consider the sum of the longest path only, right? So I hope question is clear now. Now think about the solutions. What could be the algorithms we can apply here, right? So what I am thinking is we can go with the tree traversal techniques as well. We can use any one of them because here also we have to traverse each and every node. Are you getting my point? Why I am thinking of using the make use of the tree traversal techniques, because here also we have to go and check each and every node. So one of the tree traversal techniques we can use here, right? So if we go and check, then pre-order, if we for example pre-order, so what we can do, let me add a function here. So the sum, the function name is sum, right? And here it will take the root node, right? And then current sum, current length, right? And then here sum, I will take sum s and length l. So these two are the my input output parameters, and these are the simple local parameters, right? Input parameters only, and this is also input parameter, correct? And then what I will do, I will check if node is null, then we will say return, right? Return 0, because node itself is null, right? Empty tree, so sum would be 0, correct? If now, as I am saying, I am using the pre-order, so in first we will do the OR calculation, and then only we will go left and right, right? If current length, right, current length is length of the path is greater than the length, right? If it is greater, then directly go and update the length is equals to current length, and current and sum is equals to current sum directly, right? If so, in this case, right, we have this one 4, 2, 3, 1 and 6, 4 length, right? It means now we have to consider this only, no need to check for the others, because others are having smaller length, right? This is not others are not the longest path. So if it is longest path, then just directly go and update the length of the path and the sum of the path, right? And if it is not greater, if it is equals, right, in case of multiple longest paths, so if it is equal, it means current length is equals to length, and now if it is equals and the current sum is greater than the sum, right? So you are getting it. If length is equal but the current sum is the greater than the sum, in that case, and this situation would occur in case of multiple longest paths. In that case also, just update the length and the current sum. Length would be no need to update, but still you can do, and the current sum, the sum should be updated, right? Correct. And so after this, what I will do, I will go and check for the left, and I will check for the right. So I will add sum and then node arrow left, right? Current sum I will pass, current length I will pass, and s and this length I will pass. And same I will do for the sum, node arrow right, and current sum, current length, sum and length, that I will do, and then I will close the function. So this is other small the algorithms. What am I thinking, right? It could be implemented. So here I have implemented using the in-order traversal, sorry, pre-order traversal, right? But you can make use of the in-order, post-order, level order, whatever you want, because here also, here we have to traverse each and every node. That is why I am using this one, right? So let's do the dry run for this algorithm to check if it is working or not, right? So here initially we are here 4, right? And so here we are 4, right? Current sum, current length, sum and length, correct? So now here we will go, this is not a null, right? Current length, initially current length would be 0, 0, 0, correct? So here and I forgot to update the length and current sum. So what we can do here, before checking this one, just update the length, length, current length plus plus, right? And current sum is equals to current sum plus plus node arrow data, right? This one. So here now initially these are the 0 0 0. Now when we are coming here, we will go in up. Node is not null, right? So we will go the next line and we will update the current length. Current length becomes 1. Current sum becomes 4. 0 plus 4, that is 4, right? And then we will check this condition. Yes, current length is greater than length and current sum is greater than sum, right? Because initially the sum and length are 0. So we will update this one also 4 and 1, right? And then we will go the left. Here we are coming left, correct? Now here it is not a null, right? So we will go and update the length. Current length, it becomes 2, and current sum becomes 6. 4 plus 2, that is 6, correct? And then we will check this condition. If it is greater than the current sum and length, yes, it is yes. So it becomes 2 and it becomes 6, right? And again I will go for the left from this call, right? And here I will update the current sum, that is 6 plus 7, that is 13, right? And current length becomes the 3, right? And yes, current length is greater than the length, correct? Because length is 6, current length is 3. So I will update this one also. So I will say 3 and 13, correct? Now I will go to the left of this one, that is null. So I will come back from here, right? Come back and right, from here itself I will return. That is why I will not update the current length or some whatever, right? So from the initial point where we are checking the null check, from there itself I will return here, right? And from here also what I will do, I will go for the right. Right, after this I got here 0, right? I returned from here because node arrow left is null, and then I will say node arrow right. So there also I will go right and I will come back because that is also null. So here instead of returning from here itself, you can add the if check also. If node arrow left is not null, then only you go left, or if node arrow right is not null, then only you go right. So these two checks you can add in your code if you want. Else also it is fine, right? Now from here we will return. So now we will return here, correct? Now here what is the value? So here this is 6 and 2, correct? Here, right? But or this value would be 13 and 3, it's only because we are updating this S and L, right? Length and sum for each and every node. It is by reference, right? It will be uh, basically carry on the values, right? But for this local variables, it would be here at this point, it would be 6 and 2, right? Length is 2 and the sum is 6, correct? Okay, so let me update this one. This one will be 13 and 3 itself, and this is 6 and 2. 6 and 2, correct? And now here we will go right using this call, right? And we will pass the current sum and current length 6 and 2. And here we will update the, now this is here at one node, so this one is not a null, right? So we will go down and here update the current length. So current length becomes 3, right? And current sum becomes 7, correct? It becomes 7, right? Now from here we will pass from the left. Now again we will go left here this side. So and this 3, so 3 is not greater than the current the length, so that is why we will not update the sum here. So sum is still 13, correct? Now again we will go to the left here, and this is not null, so we will update again the length, that is 4, and it becomes sum is becomes 6 and 7, that is 13, right? That is also 13. So now 4 length is there, and the sum is 13. So now what we will do, we will go and update this one because current length is 4 and length is 3 only. Sum is equals, that is fine, but the current length is greater than the whatever the length we stored, maximum length, right? That is 3. So we will update, so it becomes 4 and it is 13 only, correct? And now from here we go left, we come back, go right, and we come back because nothing is there left and right, and we come here and go right. Right is nothing, right? So still we come back, we come here and then we come here, right? Because this is the recursive call, right? So it will follow the path using which we came here, so we will come back from that path itself, right? And 4 here. So now we go here and right side, correct? And here this, let me uh, delete this one. So now we have 13 and 4, right? 13 and 4, and here the current sum here is 4 and 1, not 0 0, right? 4 and 1, and we go right, because here C++ and current sum is equals to 0 plus 4, that is 4, right? Now here we will go right, and that is 5, not null, so we will update the length. It is 2, and it is sum becomes 9. So 2 is also less than 4, so we will not update the length and sum, right? So again we will go left side, so left becomes, right, 9 plus 2, that is 11, and length becomes 3. 3 is also less than 4, so we will not do anything. We will come back here and we go right. So here at this stage, this is 9 and 2, right? So length becomes 3 and it becomes 12, right? Correct, 12. So this is also not greater than the length whatever we have already stored. Yeah. So from here we will come back, and then again we will come back, and we come out from this function. This, right? We have traversed each and every node of the given tree, right? So our final sum is 13, and our final length is 4, right? The longest path length is 4, and the sum of the longest path is 13. So this 13 would be your answer. See here, 13 is the output. So I hope you got this algorithm. So let me take you to the C++ code, right? This is the algorithm. So let me show you the code. So this is the C++ code which we have already discussed, right? We have checked for the current sum root. If root is null, then we are directly returning, right? Here, root, current sum, current length, sum and length. This sum and length are we are taking by reference, as a reference, right? So it becomes an in-out parameter basically, right? And correct. And then we are basically, see here, from this is the function. So here initially the current length and current sum is 0 0, and res and length is also 0 0, correct? So all is 0 0, right? We are passing, and we are passing the root, and we are returning the res. Res is holding the sum of the longest path, right? And here we are updating if it is not null, root is not null, right? That node, then we are updating the current sum to current sum plus root arrow data, right? And the current length is equals to plus current length is equals to current length plus 1, correct? Because we got one node, so the length would become 1. Likewise, right? Again we got one more node, it becomes plus 1, right? And sum becomes the root sum is equals to current sum is equal to current sum arrow node arrow data. That is what we are doing here. And here we are checking, we are updating the result or final result, right? The length of the tree, right? Longest path, and the sum of the longest path. That is what we are updating here, right? And then we are checking recursively for left subtree, and then for right subtree, right? And this is similar to the basically this is based on the pre-order traversal, right? I hope you understood the problem, you understood the solution algorithms, and let me know if you have any doubt or query. I will try to reply your comments, correct? So thank you for watching the complete video. See you next time. Till then, keep learning and keep exploring.